Hello, everyone, and thank you for joining today's webinar. Today's ZNCD webinar, Energy Decarbonization Blueprint, brought to you by Willdan. As you get settled, a few reminders before we get started. Please use the Q&A box at the bottom of your screen for questions today, and remember to be constructive in any of those questions or comments to the presenter and to one another to ensure we have a session that is productive. Today's session qualifies for one AIA HSW learning unit and 1 hour of ZNCD mandatory continuing education. AIA California will report this unit for those who complete the session live and will send follow-up information regarding your ZNCD certificate of completion. And as always, the webinar content and additional resources will be available online. To qualify for continuing education credit, AI California provides the learning objectives for every webinar and includes them in the presentation that can be made available online. Now to introduce our presenter. Maggie Zhu, PE, Lead AP, PMP, is a building performance consultant at Willdan with over 15 years of experience in sustainability, energy strategy, and environmental engineering. As a licensed professional engineer and certified project management professional, she brings a deep technical foundation and strategic insight to support energy efficiency and decarbonization efforts across commercial, institutional, and residential sectors. Maggie holds dual master's degrees in environmental and thermal engineering and is passionate about applying systems thinking to solve complex sustainable challenges. Maggie, thank you so much for being here today, and I'll hand it over to you.
Thank you, Sarah, for the introduction. I'm going to share my screen now. Apologize that I have some technical issue. I'll just restart the presentation. See if it works. Can everybody see my screen?
Yep, we can see it.
Okay, thank you very much.
Perfect.
Okay, great. Okay, welcome everyone. Today we are looking at a new blueprint for the building design. My name is Maggie Zhou. I'm a project manager with Willdan, and I work on the California Energy Design Assistance, the CEDA program. My background is a licensed mechanical engineer. I focus on decarbonization, electrification, and energy performance in building industry. A little bit background about the CEDA program. CEDA is a free utility program offering decarbonization consulting with no cost for the client, and we provide incentives to help maximize new construction and major renovation projects decarbonization potentials. You can enroll in CEDA by visiting our website at californiaeda.com. So for today's webinar, we have 4 main goals. The first is to identify how the grid evolution impacts the built environment. Second, address challenges in specific project types. Third, compare current grid impacts with 2030 and 2050 projections. And the last is to help you create a decarbonization blueprint for your own firm. Decarbonization has become an urgent matter. Many of you may have seen the numbers like this before. On the left, you see that the building accounts for about 40% of all the carbon emitted globally. And on the right, we are looking at how that breaks down between embodied carbon and the building operations. 72% is used in the operation of the buildings. In today's session, we are only focusing on the carbon emissions from the building operations. And nowadays, during the design, sustainability has become the goal for almost every project. But getting our clients and our design partners to launch onto sustainability design strategy is hard. In practice, I have heard every single one of these comments in the slide. Most of those points come down to three things: cost, time, or lack of interest. So when we encounter those common hesitations, it is very tempting to just put them aside. However, we must ask ourselves a different question. Have we truly solved our clients' design challenges if we deliver a building that, depreciates faster than its competitors? A building with a lower net operating income is less profitable. It remains vulnerable to weather events and occupancy discomfort. If we ignore how our energy sources are evolving, we are handing over a potential stranded assets. We should be providing a resilient investment instead. Carbon and energy are not just technical boxes. They are fundamental pillars of high quality design. While we often rely on standard rules of thumb to simplify energy and carbon decisions, it is critical to remember that those benchmarks are not static. Every project is unique. The building geometry, the owner's goals, the tenant's behavior, and the capability of the facility's staff all vary from site to site, meaning no two buildings operate the same way. In an industry where the pace of technology and regulation change so quickly, the standard advice from even 2 years ago may no longer apply to the equipment we install or the way we design today. Because nothing stays the same, we must use site-specific data to ensure our buildings are truly optimized for the current landscape. A good example of changing is electricity. People have known about the electricity since ancient times, but we have only been using it power for about 250 years. Things really started to take off when Edison brought electricity lights in the 1880s. At that time, it was a luxury for the privileged few. By 1925, only half of US households had electricity. Our perceptions of electricity has changed over time as well. In the beginning, we used it conservatively, and it was new and have a high cost and should not be wasted. Over the years, electricity become increasingly more affordable, reliable, and accessible. Today, we have an expectation that the power will always be on and will always deliver the amount that we need. We are frustrated and angry when it is not available. So there is a huge swing in the perception about electricity in about 100 years. Electricity needs to be consumed the moment it is produced because grid-scale storage is still costly and limited. As consumers, we do not use or receive electricity in a constant stream. We demand it at a different time by plugging something in or turn something on. This constant fluctuation makes it hard to predict how much energy to produce. To meet demand, utility separates generation into two general segments: base load and peak load. The base load on a grid is the minimum level of demand on an electrical grid over a span of time, such as a week. The remainder of the demand, varying throughout a day is met by systems that turn up or down quickly. So the system operators prefer a flat energy profile with a few small hills and valleys because it allows them to operate the system smoothly with the least cost. Unfortunately, this is not the load profile we have in California. The widespread solar has fundamentally changed California's load shape, creating what we call the duck curve. Between 4 and 7 p.m., electricity demand ramps up quickly just as solar generation drops. Today, that gap is mostly filled by natural gas plants. This creates a challenge. We need either dispatchable power or more flexible demand, which currently increase the cost and put pressure on utility rates. There are two ways to address this gap. The first, we can raise the belly of the duck by adding midday load through electrification and EV charging. Or we can shave the neck by shifting demand with battery storage and incentives that encourage the off-peak energy use. Today, the energy mix in California electric grid is cleaner than the national average. It includes less coal, more renewables, and more natural gas. It will continue to decarbonize with non-dispatchable solar and wind. However, the duck curve in California is going to continue to grow as the solar gets cheaper and is being required by certain building types by the energy code. The electric grid continues to get cleaner as coal is replaced by renewable and natural gas. At the same time, new restrictions and the end of subsidies are making the true cost of gas infrastructure more visible. We are also seeing stronger incentives for electrification, with renewable becoming more affordable and technologies advancing rapidly. As utility scale and distribution battery storage continue to grow, the grid of the future will be cleaner and more resilient than the one we rely on today. The electricity rate is also changing. Demand response programs provide financial incentives to reduce consumptions during peak hours. Time of use rate structures are starting to pop up where you pay per kilowatt hour changes throughout the day, with the highest charges happening during peak hours. This type of rate structure encourage customers to reduce loads when the grid need a relief. So I'm going to jump back to rules of thumb for a moment, especially that words of caution on making sure that our rules of thumb are valid. When we use rules of thumb, or when we rely on manufacturers, literature, or even when compare the energy profile of your design to other buildings, it is important that we really compare apples to apples. Climate, building type, function, forms, and size, even subtle difference like window to wall ratio, hours of operations, and usage all have a profound effects on how individual energy or carbon reduction measures perform in a building. On the right, we are listed some of the many building components that play into energy and carbon. Key point here is they all interact with each other, and each component or system can affect how we think about or design other parts of the building. I mentioned earlier that the quick pace of change in our industry, and a big part of that is in the technology that we have available. Some potential decarbonization measures include heat pump, both ground source heat pumps and air source heat pumps, VRF systems, heat pump water heating, and electric kitchen equipment. The question here is, how do we know which measure will have the most impact, especially as we focus more on carbon? Rules of thumb can help us to get the conversation started, but to really dig in for the specific of each project, I will strongly recommend using energy and carbon modeling. So there are too much changes, too many variables, and the rules of thumb alone will not solve this challenge. So what is a pathway or blueprint you can use to work toward decarbonization on your projects? Next, we will talk about the methodology for decarbonization. The tools we use to analyze how our projects interact with the grid is actually getting better and better. They are becoming faster, more accurate, easy to use, and affordable than they have in the past. All of those allow us as design professionals to tailor energy and carbon measures to the building design, respond to changing energy industry at a local level, and make more informed decisions when we are comparing all the options we have. When comparing options, it has to go beyond the rules of thumb and into project-specific studies. For energy modeling, for this purpose, we build up all the layers that affect the building performance, mainly building geometry, uses, hours of operation, assumptions on how a building is occupied and operated, and also climate and weather. The minimum requirement in the energy model is often an energy code, which set the baseline that we compare against. All those factors together drive the results in the energy model. So for the carbon reduction energy modeling, thinking about the model as comparative is important. We are not really trying to dial in exactly how much energy a building will use or how much carbon impact it has, but rather we are looking to see which measures, which systems, which components will have more of an impact than others. So we can make an informed decision on which to include in our design and which might not as important. So in the early phase, the energy model is not meant to predict exactly energy usage. Instead, they help us to guide a better design decisions. Strategies analyzed during the schematic design, such as massing, glazing, insulation, and HVAC concept, have a significant impact on the overall carbon use of the building and the longest lifespan of all the strategies. Once you have minimized your base load, then you can implement simple cost-effective systems to reduce energy usage during the design development. When you have minimized the load as much as possible, then you may consider to add on-site renewables such as a PV system. And also after the construction, people is going to operate those buildings in all the different ways. The operation strategies can cause rapid reduction or increase in energy consumption, and they need to be managed on an ongoing basis. And as for today, we are focusing on things that happen during the design. We are only going to focus on the first three buckets in this slide. So the next, we are going to walk through a few case studies from the California projects to show how those strategies play out in real buildings. We will look at the 4 building types: multifamily apartments, K-12 schools, offices, and healthcare clinic. And we will also assume that typical space type usage for each building will have about 100,000 square foot, and we will assume typical hours of operations. We will also compare 2 locations, one in Northern California and another in Southern California. Regarding to the mechanical system, we compare 3 energy scenarios with the baseline case. The 3 energy scenarios are natural gas, all electric, and more sustainable design. For natural gas scenario, the gas-fired VTAC units is used for the apartment building. And the rest of the 3 buildings, HVAC system is VEV with air-cooled chiller and the gas boiler. And the domestic hot water is gas-fired heater. For all electric scenario, we'll use air source heat pump with electric backup and electric resistance water heater for the domestic water heating. For more sustainable design, we model ground-coupled water loop heat pump and heat pump water heater. And we also made the same mechanical, architectural, and the lighting power assumptions for each of the energy model to make sure we are really compare apple to apples. So we will look at those systems in terms of carbon emissions across the different building types. We can start to see some of the patterns and the difference that affects how we might make our decisions. Before we look at those comparisons between the 4 types of buildings, I would like to share this graphs with you. This graph shows how the electricity grid in California affects the carbon emission. Here you can see there are 3 solid lines. These 3 solid lines shows the carbon emissions from the electricity grid in California. And as years goes by, you can see the carbon emission is actually getting less and less each year. This is because the electricity grid in California is getting greener and greener each year because more and more renewable energy was added to the electricity grid. And this dash line is showing the carbon emissions from the on-site natural gas. And here you can see the carbon emissions from on-site gas usage will remain constant for the life of the building. So here is the annual carbon emission by energy source for multifamily apartment projects in Northern California. 3 energy scenarios were compared with the baseline as we discussed earlier. The gas, heat pump water heater, and also a more renewable, a more sustainability design, all showed here compared with the baseline. We have three groups here. The first group is the current annual emission. The second is the average emission through 2050. And the last group is the estimated 2050 emission. That means this last group shows the carbon emission for the same building in the year of 2050. Okay, and the height of each bar shows the amount of annual carbon emissions for each scenario. Some scenario only have carbon emission from electricity, and some bars shows both from electricity and natural gas. Over the time, the carbon emission from electricity will get less and less each year, and the carbon emissions from natural gas remains the same over time. Same analysis for multifamily project in Southern California. The energy, the bars, the height of the bars could be different, but you can see the patterns is very similar. We also performed the same type of analysis for K-12 schools in both Northern California and Southern California, office buildings, health care clinics as well. And you can see from all those analyses, even though the amount of emissions is different, but they all follow the same pattern. So from the 4 building case study, we learned that why electrification is so critical for long-term decarbonization. Installing natural gas equipment in new buildings locks in carbon emission for decades, while the electric grid continues to getting cleaner and cleaner every year. So by choosing efficient electric equipment today, buildings can reduce emission immediately and continue to decarbonize as the grid improves. So the widespread building electrification is one of the most effective strategies for reducing emissions across the building environment. So now let's look closer for each building type at the carbon emission by the end use. So this graph shows the Northern California multifamily apartment projects carbon emissions for each energy scenario. It is divided by end use. These are fairly basic systems, and beyond what you see here is still lots of rooms to improve in design. What we note here is that water heating is a big part of the load for multifamily projects. And for K-12 schools, the load are more balanced compared with the multifamily project. HVAC, domestic hot water, and plug load are the big opportunities for improvement. And now we are showing the office buildings, and we note that the plug loads in office are a big part. Heating contribute a large portion in conventional gas design. Conventional VAV has less fan energy in this case because it is centralized. But for air source heat pump, it uses more fan energy because it's a distributed system. To reduce the fan power, looking opportunities in more efficient fan systems may reduce the carbon emission for this type of design. For the healthcare clinic, the plug loss plays a large portion, with fan energy coming in second. So by looking at the energy by end use, those highlights where carbon reduction effects matter most. In apartments and schools, water heating is the largest driver of emission, making it a top priority for electrification. In office and healthcare, plug loss and fan energy offer meaningful opportunity for further reduction. And I also want to point it out that the lighting updates now deliver pretty minimum additional savings because LEDs are already very high efficient. And finally, with roughly 460 million square feet of new apartments expected in California over the next 5 years, design decisions made today will have a long-term carbon impacts in the future. So on top of the energy source and end use, there are some other aspects we should consider in the design as well. This slide highlights the typical lifetimes of different building equipments and infrastructure. Some components like lighting, water heaters are replaced multiple times over a building's life, while others, such as the building envelope and the major infrastructures, can last decades or longer. Because these long-lived elements are rarely placed, the choice made during the design have an outsized and lasting impact on a building's carbon emission. That's why prioritizing low carbon strategies for long-lived system is especially critical early in the design process. And also what the occupants are doing in a building impacts the internal loads as well. As we can see from this chart, the difference between a person sleeping in a hotel room and exercise in a hotel gym is a factor of 5. Understanding how people and activity influence internal load can help us identify why a load in one area is different than another. So the building envelope and the major infrastructures is a critical level for decarbonization. Envelope decisions made early, like insulation levels, glazing, and air tightness, directly driving heating and cooling loads and lock in carbon performance for the life of the building. Additional reduction come from finding the right balance between envelope performance, building systems, and cost goals, and by carefully evaluating internal loads. A focused decarbonization analysis helps identify whether the most practical and effective carbon savings still remain. So now, as we wrap up today's discussion, I want to step back and connect the key themes we have covered, from early design decisions and long-lived systems to grid evolution and decarbonization strategies, and highlight what is all means moving forward. As the power grid continues to decarbonize, our design decision increasingly determine a building's long-term emission. The choice we make today around the envelopes, systems, and electrification will shape carbon performance for decades, long after construction is complete. Energy modeling and carbon analysis gave us the tool to design more intentionally by understanding both today's emission and how those impacts change as the grid evolves. This allows team members to move beyond compliance and make informed, data-driven decisions early when we have the greatest influence. The opportunity now is to make low carbon decision as a standard part of every project, evaluating load reductions, electrifications, and future-ready strategy as a baseline approach. By committing to those practices consistently, we can ensure the building we deliver today remains resilient, cost-effective, and aligned with long-term climate goals for years to come. That's the webinar I want to share with you today, and thank you very much. And I would like to take any questions you have. Thank you very much.
Amazing. Thank you so much, Maggie. Your presentation was great. We do have some questions in the chat, and I encourage everyone with us to continue dropping your questions in the chat. We'd like to try and get to as many of them as we can today, and if we can answer all of your questions, that would be amazing. So first one is more of a comment interested in your thoughts. Heat pumps are the most efficient active heating and cooling systems. However, the likelihood of refrigerant leakage, we need to push for heat pumps to use CO2 as the refrigerant instead. Do you have any thoughts on that? Go ahead.
Thank you for the question. Yes, I think have a low GWP refrigerant is definitely one of the measures we promote. As for the CEDA program, we do provide incentives if you choose low GWP refrigerant in your heat pump water heater for the HVAC system or for the domestic water heating, but the current threshold is 250. But this is definitely something you can consider to add into your design.
Awesome. Thank you, Maggie. And so here's a question that we anticipated. What are some of the better modeling tools, or what tools do you use?
Okay, thank you for the question. At Wilden, for the CEDA program, we actually develop some of the internal tools for energy modeling. This tool is really focused to provide to calculate the incentives, compare with the baseline. It's really focused on the to service for our energy efficient programs. But I believe with different purpose of energy modeling, there is always a better tool to meet your requirement. But again, at Wilden, for the CEDA program, we develop some of the internal tools called NEO to meet our requirement to provide incentives calculation for different projects.
Great. Thank you. Another question that we have, has the energy demand been stimulated with forthcoming increase of transportation loads? For example, if we electrify all cars, what additional demand would that need to be estimated? What would that estimate be?
Yeah, so I'm not sure if you mean is the dark shape in the current demand in the current California, because I know there is going to be more and more electricity cars demand, and the gap will be larger and larger. But to reduce that valley section, one of the strategy is to encourage the car to charge during the off-peak hours, especially during the noontime, which the PV system is provide more electricity to reduce the dark valley section. I hope this answers your question.
Thank you. Another question here that we have, when will building inspectors review thermal insulation and other carbon reduction strategies?
Sorry, can you repeat the question again?
Sure. Someone was interested. They were asking, when will building inspectors review thermal insulation and other carbon reduction strategies?
Oh, okay. I'm not sure about the building inspector. Do you mean after the construction is complete? So I just want to bring something into our CEDA program. So for our program, we do perform inspection after the construction is complete. We usually inspect the building. We don't really check how the building is performed. Our goal to perform the site visit is to verify that all the measures we submitted to PG&E are actually installed. So we basically kind of check the equipment to make sure that the efficiency really meet what we submitted to issue the incentives. So I hope this answered your question.
Yes, thank you. Someone's also interested in hearing a little bit more. What are the pros and cons of using heat pump water heaters to replace gas heaters in single family homes?
I think the pros and cons, obvious is saved energy, is more efficient, and of course, you can get some of the incentives from the utilities if you look at your local utility company, and it reduces the carbon reduction. The cons maybe it's the cost.
Uh-oh, I think she might have cut out. Is she cut out for everybody on the call? Yeah, we'll give her a second. I know that she was having a little bit of technical. Thank you guys. Oh, Maggie, I'm really sorry. Your internet cut out there a little bit, so we didn't get the answer to the cons, but I think you were about to say cost.
Oh yeah, sorry. Maybe it's some of the uh, Wi-Fi.
Yeah,
Yes, the cons maybe it's the cost and the learn curve to the new technology. People needed to learn more information, get educated.
absolutely. And I know that there are a lot of resources and information out there as well that also covers pros and cons to heat pumps.
Mm.
So keep an eye out for more of that information. And I know that's been shared a little bit too with AI California. So thank you for that question, though. Sharing more information on heat pump water heaters is always really important. With the decarbonization, electrification push, will the existing electrical grid be able to support the increased electric demand? Are there any design considerations on individual projects to support the electric grid? I know this one is a common question.
Yeah, I think maybe that's a question for the utility. The utility do they have to plan to have to increase their capability to support all the electrification and use all those you know like shifting of demand control and also different rate for different time of use. I think utility company is definitely working on that. But what we supporting from our program is definitely encouraging the new and major renovation projects to be all electric, and we provide incentives for doing that.
Awesome. And then that's perfect. Someone actually asked, what could you go over what the incentives are again?
Okay. Yes, the programs I work at is called California Energy Design Assistance Program, CEDA program. And this is a program, if you are familiar with Savings by Design, this CEDA program is a new program, replace the Savings by Design. So Willdan, we are the third-party contractor with the utility companies to provide free design assistance. We work directly with the design team to identify and identify energy saving and carbon reduction opportunities. By adapting those measures into your design, you not only reduce energy usage and cost, reduce carbon emissions, you will also receive incentives from the programs as well.
Awesome. Thank you so much. And I'm not sure if you know the answer to this specifically, or if this is just more of like a general question. But there's a question on energy storage via batteries, as a way to provide resiliency and better efficiency for renewable energy sources. But the question is about, has the lithium extraction process been assessed in terms of embodied carbon slash required water supply? And has the environmental impact of the extraction process been assessed on a site-specific level?
Yeah, so I know the embodied carbon is actually really large and brings more attention in the design. I know lots of architecture firms, when they do the design, they not only consider about the operation carbon, they also brings the embodied carbon in the design. There are lots of softwares to support this kind of analysis. Yeah, in our program, we mainly focus on the operation carbon.
Awesome. One second here. Perfect. And then I think we have another question here. Um, Actually, a couple more are trickling in. In the city of LA, they don't allow an electric tankless water heater for homes or ADUs over 500 square feet. Can you talk about why tankless water heaters and their efficiency? Can you speak to that? I don't know if that's again just like a general question or
Yeah, unfortunately, I'm not sure. I'm not familiar with that. Sorry about that.
no problem. I'm just going down the list, no problem. And someone asked again if you could repeat the program that you were just mentioning a second ago. And we might be able to add some
Um,
items to the chat as well to get some of that information in.
yes, as I mentioned, if you're interested and you have any project, either new or major renovation, ideally we want to work with you in the project early design phase. But if you have some projects already in late design phase, or even started construction, you still have the chance to participate into the program. We want to reward you for we if you already have very great design, we can also reward you for doing a great job. Again, the website is californiaeda.com. If you can check more details and contact with our outreach staff to set up a call with them to learn more details.
Awesome. Thank you. And that website was just dropped into the chat. Thank you so much, Katie.
Mhm.
Um, does the CDEA program provide free assistance for single family residential also?
Yeah, currently, unfortunately, we don't provide a service for single family. We mostly is multifamily, commercial, education, and healthcare. Yeah, we don't have for single family yet.
Awesome. Thank you. Someone's asking, one of the slides that you had earlier showed power generation using natural gas, including other means as an increase for efficiency. But in the same slide, the goal is to decrease natural gas usage in homes. I don't know if we need to pull the slide back up, but it sounded
Mhm.
like um, that maybe it looked like using natural gas addressed increased efficiency, but also it talked about lowering the usage of natural gas. So is there like a balance between the two for efficiency?
Yes. I wonder if I mentioned that the electricity grid in state of California is cleaner national wise because they use less coal and more renewable and natural gas. So that makes the electricity grid a little bit cleaner compared with the other states. It doesn't really mean, I mean, maybe that's the confusion. but the goal for our program is to get rid of the natural gas on-site usage for the new and major renovation project.
Awesome. Thank you. Are we to refer to these programs in the permit drawings, or is this a contractor's responsibility?
Uh, you mean join the SADA program?
I believe so. It just says,
Okay.
are we to refer to these programs? But I believe so.
Yeah, so the way you join the program is the first you just fill up an online application, simply put in some of the basic information, and then we will review the information to verify that if you are qualified or not. Then we will, have a couple meetings to perform the energy analysis and give you suggestions. But I want to also point it out is the design team and the owner don't have any obligation to install any of the measures, and the design team and owner is free to withdraw from the program at any point for any reason, because we see some projects maybe just stopped because of the budget or any reason. So yeah, that's how this program works.
Awesome. Thank you. Do you have any case studies from projects in the Midwest or East Coast?
Yeah, my program is really focused on this California region, but in Wildan, we do work with different utility companies throughout the whole country. And if you want to looking at some region or some state, you feel free to reach out to me. Maybe I can, make you talk with my colleague in that region.
Awesome. Thank you for offering
Mhm.
that. Um, is the CETA program only for new design? And what program would apply to retrofit of existing multifamily residential?
No, it's not only for new projects. If you do a major renovation, involves HVC, water, or envelope, it also can qualify. But again, if you're not sure, please reach out to our program outreach, give us some information. We can decide if this project qualify or not.
Great. Well, that looks like it's all of the questions. I know we're a little bit early, and I think kind of maybe a final thing that you and I had talked about is, are
Mhm.
there any other tips or tricks or best advice when you're working with customers or clients to talk about these reduction goals?
Yeah, we always encourage our customer or clients to involve into the program in the early design phase. As I presented in the presentation, the decisions you make in the early phase will have a longer term impact on the carbon emission, but there is never too late. Even some of the projects already complete design, started construction. If you come to talk to us and we look at your design, we can still reward you for doing a great job by providing some of the incentives.
That's great. Awesome. I really appreciate, Maggie, your presentation, everyone's questions. I'm happy that we had plenty of time to go through them. I'll give everybody a few minutes back to their day. Maybe you guys can scarf down your lunch in the next 6 minutes. So I really appreciate everyone being here. And again, big thank you to Maggie and Wildan for today's presentation. If you've made it this far, AI California will be sending follow-up information from today's webinar, and we'll also include information about how you can receive your Z&CD certificate. Just know we usually send them the day of, but sometimes it does take a few extra days. So if you don't receive your Z&CD certificate by end of next week, please feel free to reach out to me and we'll get you sorted out. Thank you guys again very much for today's program, and we will see you at our next AI California webinar. Thanks again, Maggie. Thank you, everyone.
Thank you. Bye bye.